Good morning. Today we are in the part B of radiography testing. In this part B, we will discuss regarding the appearances of different type of defects into your radiographic film. But before going to know how the discontinuity or defect appeared into the radiographic film and how we will interpret the data. The first of all, this is the basic responsibility of the inspector or the interpreter to evaluate regarding the film artifacts. So in this training session, first of all, we will try to understand what are the type of film artifacts is there and how we will identify the film artifacts such that it will be not interfere into our second stage of interpretations. That means for the determinations of the defects of your associated part. It may be the welded part, casting or forging, whatever the radiography has been done, the original indication of that particular job part that will be interpreted correctly. So in radiographic film interpretations, there are three steps for the interpretation purpose. One is the detection, second is the interpretation, and third is the evaluation. Detection in the sense we need to be required to gather the information regarding the for which I am going for the interpretation, why I am interpretation, and for the details of the job part related information that need to be collected before. For example, suppose I am going to interpret for a welded components. So the interpretations of weld. So what is the welding process? What are the associated defect in that particular welding process? What is the job geometry? That's a pipe to pipe, pipe to flange. So what is the configuration pipe to any kind of fittings connection is there? So first of all, as a good interpreter, we need to be required the information of your inspection part. If what is the thickness and if there is any misalignment is there or not. So these kind of general information that is the part of detection. Next, interpretation. Interpretations in the sense how determinations or evaluations of your film artifacts and as well as the welding defects, and when you will be confirmed regarding the non-appearances of your film artifacts, that means your film is artifact free, then we will evaluate the discontinuity, and that discontinuity correct evaluation, that means the nature of the defect identification is most important into the radiography. So what is the type of defects? Is the porosity, slag, crack, lack of fusion, penetration, burn through. So the nature of defect identification is the part of evaluation, and when we will be evaluate correctly, then we can able to take the decision whether this is acceptable or not as per some specific code of acceptance. So in this training programs, we will try to discuss regarding the film interpretation step, that is the film artifacts, welding defect, casting defect, forging, rolling, assembly, and the fault occurring during the handling and film processing step. So first of all, the type of film artifacts, that is light fog and radiation fog. So light fog and radiation fog, that is the first film artifacts that can be appeared into your radiographic film, and this is due to the exposure of light while it's covered with the interleaving paper, or it is due to the radiation, X-ray or gamma rays, that is unfortunately absorbed by your film and it has been exposed by the radiation without any requirement. And if that's occur, the appearances into the radiographic film like will be this kind of foggy appearances, black dots, foggy appearances into the radiograph. This is due to the light fog or radiation fog. Third one, there is a possibility of fog density in your film due to the safe light fog. And this safe light means normally we are cutted the film, loaded the film in a dark room where we are using the red light. But if there are some leakage into the red light containing light holders, and if in presence of red light, others light like that of part of the white light that will be much more present there. So according to that, there is a possibility of the leakage of the other lights, and that safe light fog can be generated into your radiographic film. And the same black dotty appearances in the form of fogness that can be hidden. The white light is leaking from the slit into the safe light. This is the cause for your safe light fog. Uh, Third one, that is known as the fault associated with the before development. That means if we are going to start the development process of your exposed or as exposed film, but before that, there is a possibility of dirt deposits into the intensifying screen. There is a possibility of formations of dark spot due to the lower density and huge density in your radiograph, and the water or the fixer solution can have a possibility of spattering due to the what I can say the unexperienced technician who is working into the dark room, that can produce the splashing of the water or fixer solution before the entire film has been processed. So these can cause this type of film artifacts, that means due to the appearances of the unjustified or unwanted material in between the LED screen and film. This kind of white patchy appearances may be there. This kind of dark deposits can be there, or white appearances like that of spatter due to the flashings of the chemicals. So these are the film artifacts. Third one, that is fault associated with the loading and unloading system. We know that in the dark room, the cutted film from the box and then by the cutter and by the cutter or scissor, whatever we are using, and after that the film is occurred into the interleaving paper. We are removing the film from the interleaving paper, and then it is placed into the intensifying LED screen, front and back LED screen, and then the film is inserted into the PVC envelope. But during this process of operation, say the air conditions or the temperature of the dark rooms or the film box has been not maintained properly, then the film's emulsion will be swelled, and due to that it can be attached to each other. This is known as the film adhesion. And if the film adhesion is there due to the high temperature or high humidity atmosphere, then the appearances into the film will be like that black dark deposits. This is due to the film adhesions. In some cases, when we are trying to taking the film from the interleaving paper, due to the static electrical discharge, there is a possibilities of the static smoke. And when we are cutting the film by using the cutters or something, scissors, and if we are make maximum pressure to cut this one, so there is a possibility of kink or bend mark. Whatever the activities will be done, that will be reflect into your radiographic films, and that kink mark is also one kind of film artifacts. Next, the fault associated with the post-development process. First one, black dark deposits, whatever into the film is concerned, that is due to the uneven fixing. And third one is the white spotty appearances, patchy appearances into your radiograph, that is due to the uneven drying. So the temperature of the dark room need to be maintained correctly. Water, whatever the flowing water, running water shall be contaminated with any kind of oil contaminations into the tank edges, into the water running water. There is a possibilities of depositions of the water molecule during the drying, and if it has been not dried correctly due to the uneven drying, this kind of whitey patchy appearances is there, and these all are the film articles. So after the interpretations of the film artifacts, if it is interfering your area of interest, that is weld plus heat affected zone, then the film need to be take another time, that is the retake. And if it is the defect artifacts free, then you can proceed for the interpretations of your suppose welded radiograph, the welding defects. It's a casting radiograph, the casting defect. If it is a forging or assembled part associated with the fabricated part is concerned, type of defects we need to be try to understand how it will be active. So, in the case of welding, we know that the welding is carried out into the four passes: root, hot pass, fill up, and capping of final. During this stage of welding process, we know there are different type of welding defects is associated, which can be identified by the radiographic operation, like lack of penetration, lack of fusion, porosities, slag inclusion, root undercut, crown undercut, inadequate weld reinforcement, mismatch, excess weld reinforcement, weld spatter, arc strike, viscaria burn through, and tungsten inclusion in case of GTAW welding process. We can see you here visually how it will be appeared, that is the porosity, crack, lack of fusions, burn through, arc strikes, the type of defect which can be visually identified. The first of all, before going to take the radiography, the inspector need to be visually identified regarding the appearances of the defect. The first one, that was the visual impressions of the weld root defects, and here it is the visual impressions of the weld defect from the fill up or capping. So in the capping, the same kind of defects can be originated, and visually we can able to interpret like that of porosity, cap undercut, slag inclusions, incomplete fill up, and arc strike. So after the visual inspection has been completed, then we are taking the radiography, and in the radiography we are interpreting in sense of some the appearances, black and white images of that particular defect. So first of all, we will discuss regarding the cold lap. So cold lap is the conditions where the weld filler metal does not properly fuse with the base material or the previous weld pass material, that is the interlap cold lap, and the arc does not melt the base metal sufficiently, and because slightly molten fluid flow into the base material without bonding, in radiographic it will be appeared into the white patches into the center of the weld. Next welding defect that can be easily identified, that is the porosity. Porosity, we know it is the gaseous entrapment into the weld during the solidification process. This porosity will be appeared into the radiographic film in a black dots. It may be in regular rounded indication shape. Otherwise, it may be in sometimes elliptical or elongated in form also. Depending upon the appearances of the gaseous entrapment of porosity, we need to be identified the nature of porosity, like that of a random isolated, it may be aligned or it may be the cluster. According to that, we need to be taking the decision whether it is acceptable or not, as per ASME section 5, ASME section 8, division 1, appendix 4, that is radiographically determined rounded indication. In our next classes, we will elaborately discuss regarding the acceptance standard and codes of welding. Uh, Next one, that the welding defects, that is the clustered up porosity. Here, that is the black dots, but the localized area, lot of porosity is there, and the clustered up porosity will be appeared into the radiographic film in the form of rounded black dots in a localized area. Slag inclusions, it is the oxides coming from the flux material of your inspection part, or it may be from the covering material of electrode, or otherwise in some cases like that of SAW or in FCW welding process, we are additionally using the flux. And the flux is normally, we know, it is acting for the blanket, that means it will protect the weld pool during the solidification from the gaseous entrapment, but after the solidification, we need to be remove the slag material. But if that is entrapped into the weld, then it will be considered as a slag inclusion. The appearances of the slag into the radiographic film, that will be irregular dark indication. The first of all, the appearances of the slag is irregular in nature. The dark irregular indication, that will be the indications of the slag here. Next one, the incomplete penetration or lack of penetration into the roots region. We know it's the metal not fails to penetrate into the weld roots area, and the appearances into the radiograph here, it is a dark area with a well-defined straight edge that follow the land of root face down to the center of the weldment. At the center of the weld, there will be a straight line band like that of rubber band that we can be identified so easily. Incomplete fusions is a condition where the weld filler metal does not properly fuse with the base metal, and the appearances of the radiograph usually appeared as a dark line or line oriented into the directions of the weld seam along the weld preparation or the joining area. So lack of sidewall fusions, that is, it may be the transmitted black dots, or it may be a very straight line with a sharp edge that can be identified into the radiographic film. Internal concavity, next defect is your internal concavity, and that is also known as the suck back, and that is due to the conditions where the weld metal has contracted as its spool and has been drawn up into the root of the weld. On the radiograph, it looks similar to the lack of penetration, but the line has irregular edges and it is open quite wide in the center of the weld image. Next one, that is the internal or root undercut, and it is the erosions of the best metal next to the root of the weld. And in the radiographic image, it is appeared as a dark irregular line offset from the center line of the weld. Undercutting is not a straight edge as lack of penetration because it does not follow a ground edge. So in root undercut, the undercut into the root region, we can be identified in sense that in between the root and hot first, there is a dark line running parallel to the root, but it is zigzag in nature, not the straight line. Next one, the external or crown undercut, the same, that is dark irregular indications running parallel to the weld in between the weld and parent metals, that is the cap undercut, and the erosions of the material into the base material is the cause of the surface undercut. If your joint has a welded joint has a mismatch in the sense there is a thickness variation, or there is a offset angular displacement is there, the appearances of the weld will be like that, but a mismatch up to certain degree is acceptable until other welding defect like that of lack of penetration, too much undercut, and lack of fusion. This kind of severe welding defect is not appeared by the skilled operator, then offset is acceptable up to the some length. The difference in the density is caused by the difference in the material thickness. The dark straight line is caused by the failure of the weld metal to fuse with the length area. If it is not appeared that one, so the mismatch will be acceptable. This is the image of the inadequate weld reinforcement. That means we have not completed the weld capping as per the requirement of code. So when the thickness of the weld metal deposited is less than the thickness of the base material, it is very easy to determine by radiograph if the weld has inadequate reinforcement. So yeah, incomplete fill up. Because the image density in the area of suspected inadequacy will be higher or darker than the image density of the surrounding base material. This is the excessive weld reinforcement, that the cap is so much high that the area of the weld, that is weld metal added in excess to the specified by the engineering drawing and codes. The appearances of the radiograph is a localized lighter or white area in the weld. The visual inspection is easily determined the weld reinforcement is it excess of that specified by the engineering drawing. Next, the cracks. The cracks can be detected in the radiograph only when they are propagating into the direction that produce a change in thickness that is parallel to the X-ray beam. Cracks will appear as jagged and often very faint irregular line. Crack can sometimes appear as a tails on inclusions or porosity. The appearances of the cracks may be into the longitudinal in direction running parallel to the weld, and it may be into the transverse of the weld. When it is in transverse in nature, it's known as a transverse crack. It is very difficult to identify the transverse crack by radiography due to the parallel radiation beams with that particular defect. But the transverse crack can be identified so correctly. This is the tungsten inclusion in GTAW welding process. We know tungsten is the inert electrode, normally using into the GTAW, but due to the contaminations or uncontrolled way of welding, if tungsten has been melted and deposited into the weld, then it will be known as a tungsten inclusion. Only tungsten is a higher dense material compared to the steel, so that's why it will be appeared in a white patchy area. It may be the regular or in irregular shapes, but the appearances will be the white. This is the oxide inclusions, that is black irregular like that of slag, visible into the surface of the material being welded, especially into the aluminium. Oxide inclusions are less dense than the surrounding material and therefore appeared as a dark irregular shape discontinuity into the radiograph. And in case of GMAW, particularly welding, the discontinuity, which is known as the whiskers, are the short lengths of weld electrode wire visible onto the top or bottom surface of the weld and contained within the weld. On a radiograph, they appear as a light wire-like indication. And next one is the burn through. Burn through results when too much heat cause the excessive weld metal to penetrate the weld zone. Open lumps of the metal sag to the weld, creating a thick globular condition onto the back of the weld. These globes of the metal are referred to the isles. On the radiograph, burn through appear as a dark spot, which is often surrounded by the light globular area. So this is the indications of burn through. And next, we will try to understand the type of casting defect and how it will be appeared into the radiograph. Into the castings, there are filling related defect like a blowhole, sandhole, sand inclusion, cold lap, misrun, and gas porosity. In case of shape-related defect like that of mismatch, misrun, distortion, wrap, and flash. In case of thermal-related defect like that of hot tears, cracks, shrinkages, dendritic, or filamentary or spongy appearances, and sink mark, and the defect by the appearances that may be metallic projection, cavities, discontinuity, incomplete casting, or rat rail, buckles. In generally, the defects and its shape, location, and indications can be shown in this table. A shrinkage, it is a linear type of defect, and indication is black line in nature, and surface are internal. In both area, it can be appeared. Hot tears, it's a surface defect, linear in nature, black lines. Cold shut, it is a surface defect, linear in nature, black line appearances. Porosity, it's a rounded nature, black spot. It may be appeared into the surface, internal, or in root area. Non-metallic or metallic inclusions, it's round in shape, black or white, depending upon the density, and it can appear into the surface and into the internal of the casting. These are the type of appearances into the radiographic film of castings. First one, that is the sand inclusions, irregular rounded black dots. Porosities, that is the rounded black dots throughout the casting body. Shrinkage cavities, cavity due to the shrinkages like that of root concavities into the welded component, and it is the dendritic appearances. That's one kind of shrinkages crack. Next one, it's a hot tears or cracks due to the threaded areas where the cross-sectional variation is there. It's a type of slag inclusions into the casting. It's a core shape and the spongy appearances into the magnesium or non-ferrous material casting. In the same way, like that of forging and parent material inspection, we can able to interpret the appearances of the defects like that of unfilled section into the forging, cold shut, scale pit, die pit, and improper gain flow. In case of parent material inspection, surface irregularities like that of rust and weld spatter, notch grooves, loose metal in surface roughness, porosity, metallic inclusion and non-metallic inclusion, lamination and high hydrogen content cracking that are the cause of the defect into the parent material, and it can be interpreted through the help of radiography. But the thing is, in case of origin, it is best to use the ultrasonic process to establish or identify those defects. In radiography, we are following different type of article. You know, a semi-section 5 article 2, that is for the radiographic specification, and along with that we can follow the extended article of article 22 in ASME section 5, that is the radiographic standard, and in article 22 there are a lot of sub clauses is there. SC 94 standard guide for the radiographic examination, SC 747 standard practice for the design, manufacture and material grouping classification of wire type IQI, AC 999 standard guidelines for controlling of quality and industrial radiographic film processing, AC 1025 standard practice for design, manufacture and material grouping classification of whole type image quality indicator, AC 1030 standard test method for radiographic examination of metallic casting, and AC 1114 we are using for the determination of the size of iridium 192 source. AC 1165 standard test method for the measurements of focal spot of industrial X-ray machine by pinhole imaging. AC 1255 standard practice for radioscopy, and AC 1416 standard test method for the radiographic examination of involvement, and AC 1647 standard practice for determining the contrast sensitivity in radiology. So these are the types of code you can learn for the betterment of your knowledge regarding the film interpretation. In your next classes, in next session of radiography, we will be interpreted the codes according to the standards is there. For the refinery process piping B31.3, we will discuss according to the pressure vessel ASME section 8, division 1, division 2, division 3, and for the power piping B31.1, for the structural steel fabrication AWSD 1.1 acceptance standard, for the welder qualification ASME section 9, and for the storage tank gauges API 650, and for your cross-country pipeline API 1104. In our next session, we will elaborately discuss the different type of acceptance standard of radiographics interpretation. So after interpreting the radiographic film and the observations of the correctness of the defect, we need to take the decision whether it is acceptable or not as per the reference code. So we will learn in our next class regarding the type of codes. Yeah, what are the codes that we are using for the interpretations of our radiograph. Thank you for today's session. We'll meet in the next session for your information regarding the code and standards. Thank you.